All right, so today we're going to be talking about factoring the GCF from expressions with rational exponents. So remember, a rational exponent, a rational number is a number that can be made into a fraction. So today, all of your exponents are going to be numbers that are fractions. And we're going to do 6 examples. If at any point you feel like, hey, I understand this, then you can go ahead and get started on the homework. If you get stuck, you might want to come back and finish looking at the rest of the examples. So here's the first example. Now, what you're going to be doing is you're going to be factoring the GCF from each. The GCF is always going to be the one with the smallest exponent. So for example, from x to the 1/2 minus x to the 5/2. The exponent 1/2 is smaller than the exponent 5/2. So that's what we're going to factor out. So x to the power of 1/2, and I have to think what's left over inside of my parentheses. So x to the 1/2 times what will give me my first term back? Well, 1. Now, x to the 1/2 times what will give me x to the 5/2? Well, remember when you're multiplying, you add exponents. So if I have an exponent of 1/2, I need an exponent of 4/2 to give me x to the 5/2 back. Just kind of like a little side note over here. If you're distributing back in x to the 1/2 times x to the 4/2, remember that's x to the 5/2. So this should be x to the 4/2. So your final answer is going to be x to the 1/2 times 1 minus x squared, because 4 over 2 simplifies to be just 2. And this is going to be your final answer here. Remember, we're just factoring out the GCF. So even though this is a difference of perfect squares, I'm just going to leave it like that because we're just factoring the GCF. So next example here. From each term, I look at, here's one whole term, and here's one whole term. Well, I notice that I have 2 factors here. I have x to the negative 1/2 and x plus 3 to the 1/2. So between those two, I'm going to look at both terms, and I want to see what's the smaller exponent. So from x to the negative 1/2 and x to the positive 1/2, I know that negative 1/2 is the smaller, and so I'm going to factor that out. From x plus 3 to the positive 1/2 and x plus 3 to the negative 1/2, I know that the smaller one is negative 1/2. So when I go to factor, I'm going to factor out this guy here, x to the negative 1/2, and this guy here, x plus 3 to the negative 1/2. So that's my GCF. My greatest common factor is x to the negative 1/2 times x plus 3 to the negative 1/2. So that's what comes outside. X to the negative 1/2 times x plus 3 to the negative 1/2. Now when I factor that out, I have to think, okay, what's left from this first term when I factor it out? Well, I've got nothing left here, so that's just 1. X plus 3 to the 1/2. When I factor x plus 3 to the negative 1/2 out, I know that when I multiply these, I would add my exponents. So negative 1 plus 2, remember negative 1/2 plus 2/2 would give me 1/2. That's what's going to give me this back. So that's what's left over from my first term. From the second term, I know that x to the negative 1/2 times x to the 2/2 will give me that x to the positive 1/2. And x plus 3 to the negative 1/2 times, well, times just 1, so I don't have to put anything, will give me this other part back here. So you can always double check by distributing back in. is it true that that times this first part here will give me this? Well, yes, it will. Is it true that that whole quantity times this will give me my second term? Well, yes, it does. It's true. So we've factored out our greatest common factor. Now, I'm just going to simplify a little bit. And this is x to the negative 1/2 times x plus 3 to the negative 1/2 times, well, 2 over 2 is just 1, so this is just x plus 3. And 2 over 2 is just 1, so this is just x. And this is your final answer down here. And that's example number 2. Okay, example number 3. So we've got 3 terms here. Term 1, term 2, and term 3. So I look at the exponents and I need to ask myself, well, what is the smallest exponent between 3/2, 1/2, and negative 1/2? The smallest exponent is negative 1/2. So I'm going to factor out an x to the negative 1/2. So my GCF is x to the negative 1/2. That's what I'm factoring out. Now, x to the negative 1/2 times what would give me this x to the 3/2? Remember, you add exponents, so I need x to the 4/2 here. Negative 1/2 plus 4/2 will give me 3/2. For my second term, you know you have 8 times x to the, and negative 1/2 plus 2/2 would give you positive 1/2. For the third term, you're going to have 15 and just 15 because x to the negative 1/2 times 15, it gives you your third term back. And you can always double check, is it true that this times this gives you your first term? Yes, it's true. Is it true that your GCF times your second term gives you this second term up here? Well, yes, it's true. Is it true that your GCF times 15 gives you this third term? Well, yes, it's true. So we factored it. And I'm just going to simplify my exponents. So x to the negative 1/2 times x squared plus 8x plus 15. And notice we're just factoring in GCF today, so I'm just going to leave it like that. And that's example number 3. So 3 more examples here. Example number 4. So I've got 3 terms. 1, 2, 3 terms. And all of those have an x plus 1 to the power of something, an x plus 1 to the power of something. So I know that I want to find the lowest exponent. So between 1/2, 3/2, and 5/2, 1/2 is the smallest exponent. So I'm going to go ahead and factor that out. So that's my GCF. So I have x plus 1 to the power of 1/2. That's your GCF. From this first term, when I factor that out, I'll just be left with 4. From the second term, I'll be left with minus 5 times x plus 1, and I have to think about 1/2, x plus 1 to the power of 1/2, times x plus 1 to what power would give me 3/2. Well, remember that when you're multiplying, you add exponents. So I know I need 2/2. 1/2 plus 2/2 is 3/2. Now the last term here, x plus 1 to the power of, well, I know when I multiply, I add exponents. So 1/2 plus 4/2 will give me this 5/2. And you can always double check. Is it true that my GCF times 4 gives you this first term? It's true. Is it true that the GCF times the second part gives you your second term? Yes, it's true. And is it true that your GCF times this third part gives you your third term? Well, yes, that's true. So you know that you factored it correctly. So I'm going to go ahead and simplify my exponents. So we've got x plus 1 to the power of 1/2 times 4 minus 5 times x plus 1, 2 divided by 2 is just 1, plus x plus 1 squared. 4 divided by 2 is just 2. And so here's your final answer. Okay, 2 more examples. Again, we're looking for the smallest exponent between 1/2, -1/2, and -3/2. Well, the smallest exponent is -3/2. So that's the one that I'm going to factor out. And, so I'm going to have x to the -3/2. Now we have to think about what's going to be left inside these parentheses to give us the original expression back. So I'll have 2x to the power of, and remember you add exponents, so -3/2 plus what would give you 1/2? Well, that would be 4/2. -3 plus 4 is 1. And then plus 5 times x to the, you have to think again what exponent would add with -3/2 to give you -1/2, and that would be 2/2. And then plus just 2 for your last term. X to the -3/2 times 2 gives you your original back. And now again, we double check. Does this GCF times this first term give you 2x to the 1/2? And it does. Does this times the second part here give you your second term? And yes, it does. And then does that GCF times 2, does that give you your third term? Well, yes, it does. So that means that your final answer here is x to the -3/2. Great. Here we go. Okay. So final answer is x. Why am I doing purple? This is so confusing. Have to have weight. Okay. All right. So it's x to the -3/2 times 2x squared plus 5x plus 2. And that would be your final answer with just the GCF factored out. Okay, almost last problem here. So, smallest exponent between 7/2 and 3/2 is 3/2. So I'm going to factor out x plus 2 to the power of 3/2. From my first term, you're going to be left with x plus 2 to the power of 4/2. 3/2 plus 4/2 is 7/2. And then minus 1. Okay, because when you factor the whole term out, there's still a 1 left. And just simplifying, you get x plus 2 to the power of 3/2 times x plus 2 squared minus 1. We'll just leave it there. And factor to GCF. Last problem here, and this one's a little bit more complicated. So I'm going to just look at the numerator first. And in the numerator, you can see that there are 2x minus 3's in each term, and there's x's in each term. So you have 2 factors in each term, well, and the coefficients also. So I'm going to look at each one of those separately. And from this first term, I know that 1 is the smallest exponent of the x's. Okay, if you look at all these exponents, 1 has the smallest exponent. And so I'm going to factor out an x. Okay, so I'm also looking at the 2x minus 3's, and I've got -2/5, 1/5, and 4/5, and I know -2/5 is the smallest. I'm going to factor out a 2x minus 3 to the power of -2/5. I don't want this big thick stuff. Pen, color, white, thin. Okay, so we had x and 2x minus 3 to the power of -2/5. Now let's think about what's left over. For my first term, I'll be left with 3x, and the 2x minus 3 to the -2/5 is all factored out. plus, here I'm left with 4x squared times, now remember I'm thinking multiply, you add exponents, so negative 2/5 plus what will give me 1/5? So I have 2x minus 3 to the power of 3/5. And then we already factored out the x from that third term, so I just have minus 2x minus 3 to the power of 6/5. Okay, negative 2/5 plus 6/5 would give me that third term back. Now the denominator stays the same, except from squaring it. So remember when you do power to a power and you square something, you have to multiply. So my denominator becomes 2x minus 3 to the power of 6/5. Well, I've factored, and I noticed that these have the same base. So you can subtract your exponents. So when I do that, negative 2/5 minus 6/5 is negative 8/5. So negative 8/5. So I end up with x times 2x minus 3 to the power of negative 8/5 times 3x plus 4x squared times 2x minus 3 to the power of 3/5 minus 2x minus 3 to the power of 6/5. And that right there is your final answer. Okay, we factor the GCF out and we simplified the denominator.